Yeah, good evening, everyone. So, as already we have discussed about the partial fraction method in the previous class. Now, just continuing to that class, I'm going to take few sums, how to apply the partial fraction technique or method to solve a particular integral functions. Okay, so let's have a discussion over here. Yeah, I'm taking the question from NCERT textbook itself. Yeah. Now, see. The technique which we are using is partial fraction technique. Partial fractions method. So already you know very well the partial fraction method is used to what? Just to convert the complex proper fraction, complex proper fraction into a simplest proper fraction. Simplest proper fraction. It is the purpose of this is to what? The complex proper fraction to simplest proper fraction. If it is not a proper fraction, then we'll go for the long division method to convert them into proper fraction. And a condition to apply a partial fraction is what? Denominator must be what? Factorizable. This is a minimum condition. Factorizable hona chahiye. Then only you can use the partial fraction method. So already I have explained how to break the fraction by introducing few constants. Now we'll also discuss the same point through questions over here. So I'm taking the question like it's an example number 12 from the textbook itself. I'm taking example number 12. The integral of we need to solve like uh, okay, instead of example number 12, I will go with first example number 13 and then I'll come back. Example number 13 I am taking. Example number 13. So it's the question is like integral of 3x minus 2 upon x plus 1 the whole square into x plus 3. Right? So this is the question. Now how to start with? If you look at this one, first of all, denominator is completely factorizable. Already factorizable form में दिया है. Second thing, the degree of the numerator is less than the degree of the denominator, means it's a complete complex proper fraction. It's a proper fraction, denominator is factorable. Two conditions are fulfilled, then I can use partial fraction method. So when I'm using partial fraction, integral symbol will not be taken. Okay, so first take the function out like 3x minus 2 upon, I can go with like x plus 1 whole square into x plus 3, right? So in this way, if now first I am going to split this fraction into some parts, so how many parts I'm going to get? If you count the factors, there are total 3 factors. Okay, x plus 1 the whole square is considered as 2 factors and x plus 3 power 1. So total there are 3 factors going to get fractions. So first fraction is a upon x plus 1, then plus b upon x plus 1 the whole square, like this. So if power is 2, we'll start with power 1 and then power 2. If power is 3, then 1, then 2, then 3, like that. So power is increases step by step, right? And then the third factor is obtained, that is c by x plus 3. So if you take a LCM on both the side, then you can find the value of A, B, and C separately, one after the other. See how can we solve that one. So if you take an LCM and all, LCM would be remain same. So that would be get cancelled, like 3x plus 2 upon what you will get, like x plus 1 the whole square into x plus 3 is equal to LCM would remain same. जो यहाँ डिनोमिनेटर है वही LCM दोबारा आएगा यहाँ भी, वो दिमाग लगाने की जरूरत नहीं है. x plus 1 whole square into x plus 3. This is always going to get cancelled in the next step. So if it is an LCM, then ultimately it would come like a into x plus 1 into x plus 3, then plus b into it would be x plus 3, then c into what you will get x plus 1 the whole square, right? So now we are left with only this one which is left c. मैं यहाँ से स्टेप थोड़ा लिख के बता रहा हूँ आपको just because of beginning sum. So 3x plus 2 is equal to, we are left with a into x plus 1 into x plus 3 plus b into x plus 3 plus c into x plus 1 the whole square. Now our purpose is to what? We first find how to find a, b and c by substituting the value of x on both the side. So which x has to be taken? That you can think. If I substitute x is equal to minus 1, right? So ultimately this is going to 0 and this is going to 0, means a and c will be eliminated. I will be able to find the value of b, right? So first that I'm going to take. So let x is equal to minus 1, means always choose the value of x in such a manner, right? E one of the ABC वैल्यू इज बिकम जीरो, है ना. इसका जो फैक्टर्स होते हैं उन्हीं में से कोई एक वैल्यू ऐसे सब्स्टिट्यूट करिए ताकि वो ए बी सी में से या तो एक वेरिएबल या दो वेरिएबल एलिमिनेट हो जाए, सीधा एक वेरिएबल की वैल्यू हम फाइंड आउट कर सके. So if I put x is equal to minus 1 on both the side, the left side become 3 into minus 1 is minus 3 plus 2, that is minus 1, equal to, I'm not writing this a part because it is going to be 0 only, and b into what, minus 1 plus 3, that is 2, and c is going to 0. So ultimately the value of b will become minus 1 by 2. So I got the b value. In a similar manner, right, you can consider it as a equation 1. Again take another value of x. इसी तरीके से आप next value put करिए, like put x is equal to, now I am taking to make b 0, so minus 3 I am taking. So if I take x is equal to minus 3, then ultimately left hand side becomes 3 into minus 3, minus 9 plus 2, it will be minus 7 is equal to, so माइनस से सब्स्टिट्यूट करूंगा तो a 0 हो जाएगा, ये b वाला पार्ट 0 हो जाएगा, वी लेफ्ट विथ ओनली c, राइट. सो माइनस 3 पुट करो तो माइनस 3 प्लस 1 minus 2, minus 2 the square is 4. So then finally I will get c as 4, sorry, minus 7 upon 4. So I would be able to get the value of c. Now what left, मुझे क्या मिल गया, b और c मिल गया. अब a हमें रिक्वायरमेंट है, सो b और c में से किसी को भी हम जीरो बनाने की कोशिश करते हैं, ये ऑटोमेटिकली जीरो हो रहा है. तो इन दैट केस देन टेक x इज इक्वल टू 0. दिस इज द सिंपलेस्ट वे टू रिड्यूस द इक्वेशन इनटू सिंपलेस्ट फॉर्म. 0 पुट कर दो x की वैल्यू दोनों तरफ, तो अल्टीमेटली द लेफ्ट हैंड साइड इज 2 and the right hand side become what, a into, if you substitute 0 over here, then we are left with 1 into 3, that is 3, then b into 3, then c into 1, and already you know the value of b and c, then substitute and simplify, that's it. So 2 is equal to 3a plus b into 3, yeah, 3 into minus 1 by 2 plus c की वैल्यू हो गया minus 7 by 4 into 1 या only minus 7 by 4. So now you can take these two fractions to left hand side and you will be able to get the, by solving this you will be able to get the value of a as 11 by 4. I'm not solving here, but you can solve and you can get the answer by simplifying this. So now I'm able to read the value of a, b, c, which I have introduced in the beginning of the solution. Like here, the value of a I can substitute, value of b I can substitute, value of c I can substitute in the beginning, right? So that the entire fraction is converted into three simplest fractions. So I'm substituting now ABC in the beginning. See how it will reduce to a simplest form. Chलिए. Yeah. Now see the total question is now going to reduce to like the fraction is going to reduce to देखिए आप यहाँ से I'm just changing the pen color so that you can enjoy the colors while observe this video. Fine. So here you can take like the question 3x minus 2 upon the x1 x plus 1 the whole square into x plus 3, right? It is going to reduce like a upon it was a was 11 by 4. I can keep 11 by 4 upon x plus 1 plus value of b was minus 5 by 2 I think something था वो b की value minus 5 by 2, so minus 5 by 2 and what was that? Might be I did not remember, but it was like that only. A upon x plus 1 the whole square, and it was like the c value was something minus 7 by 4 upon x plus 3. That's it. Now if you want to do the integration of this fraction, it nothing but just you need to do the integration of all these three parts with respect to x, or you can say with respect to dx. So since they are the constants, you can keep this constant outside. इसको आप बाहर ले सकते हो. अगर हम बाहर ले ले, so ultimately 11 by 4 into, right? We are left with 1 upon x plus 1. Similarly, here it would be minus 5 by 2 into 1 upon x plus 1 the whole square minus 7 by 4 into 1 upon x plus 3 dx. So everywhere dx would be there. It's a common one. Don't forget to write. Then 11 by 4 into, it's in the form of 1 by x. It's a linear one, so you can apply that. 1 by x integration is log x, so log of modulus x plus 1 minus 5 by 2 into, it is not the linear, so you cannot say it's log of x plus 1 whole square. Remember, it's not a linear function, it's a quadratic function. So how we can reduce this? Just by assuming x plus 1 is equal to t, its derivative becomes 1. Hence, the next step, it's going to reduce like dt upon t square. if you go for the substitution technique over here for the second integral only, and 7 by 4, and since again it's a 1 by x, that is a linear form, you can apply log of modulus x plus 3, and you can write it as plus c over here. And finally, the answer would be 11 by 4 into log modulus of x plus 1 minus 5 by 2 into it become t power minus 2. So t power minus 1 by minus 1 minus 7 by 4 into log of modulus x plus 3. So now you can reduce this minus and minus plus, and you can substitute the t value as x plus 1 in the question, and this would be your last step of the solution. So this is the integral part. Okay, the upper part is completely partial fraction technique. So by using the partial fraction technique, I was able to convert the complex fraction into a simplest fraction. This is a journey, complex to simplest. So to convert complex into simplest, the condition is must, denominator must be factorizable, and it must be a proper fraction. So both the conditions are fulfilled, then I can go for what the partial fraction technique. And since here the total factors are 3, hence this fraction is going to be split into 3 fractions. Fine. I hope you definitely understood this one, right? So we'll take the next question to understand more, right? So next question I'm taking, yeah, like example number 16 I'm taking, example number 16, right? Example number 16. So I will just again I'm changing the pen color so that you can identify the different sums. Okay, fine. Just go with this one. I is equal to, we need to solve the integral. I is equal to, question is x square plus x plus 1 upon x plus 2, the linear factor, into a quadratic factor, that is x square plus 1 dx. So now again you can see the denominator is completely factorizable, right? And it's a proper fraction because the total product degree of the denominator is 3, degree of the denominator is 2, hence it is a proper fraction. You can go with the partial fraction technique. So I'm using again which technique here? By using partial fraction method. So I'm going to express this into two simplest fractions. Fine. So first I'm taking the function as it is, x square plus x plus, and while applying this method, no integral symbol is followed because we are not doing the integration, we are just doing the partial fraction method. So don't take the integral sign along with this. And then since the first factor is linear in nature, okay, we'll take the constant in the numerator as a upon x plus 2. And since here the second factor is quadratic in nature, so we'll take the linear function as a numerator part. This has to be understood by everyone. When you are taking a quadratic factor, you need to take the linear one like bx plus c, right? And if it is a linear factor, so you can introduce the only single constant. It has to be a proper fraction only again. So now again take the LCM and all, and you have to find out the value of a, b and c, and this total will be integrated thereafter. So once you take the LCM, so LCM will be get cancelled on both the side. So directly I'm writing the step what is left after the LCM. X square plus x plus 1 is equal to a into x square plus 1 plus bx plus c into x plus 2. That's all. Now, in this result, then substitute the suitable factors of x to get the ABC value. So, if I substitute x is equal to minus 2 on both the side, this entire factor is going to be a 0, then I will be able to get the value of a. So, that is why purposely I am taking let x is equal to minus 2, then left hand side becomes 4 minus 2, 2 plus 1, 3 is equal to a into 4 plus 1, that is 5, and rest of the part becomes 0. So from here I would say a would be 3 by 5. So I will able to got the value of a. Now to get the value of b and c, because there are three variables to solve. To get b and c, I cannot make 0 here, because since it's a perfect square, a cannot be 0, a factor cannot be 0. Then I will go with the random substitution of x. Random substitution, it may be any value of x. So I will take 0 first. If x is equal to 0, the left hand portion will be 1, and the coefficient of a would be 1. Then b would, yeah, b into 0 will be 0, right? So b into ये 0 हो जाएगा. Then c into 2 is left. So finally the equation becomes like 1 is equal to a plus 2c. So ultimately I can substitute the value of a, or I can first solve for c, like it is 1 minus a, or 2c is equal to 1 minus a, or 1 minus 3 by 5. It would be 2 by 5. 2c is 2 by 5, so c will be what? 1 by 5. So I'm writing c is equal to 1 by 5. So I got c as 1 by 5. Now, in a similar manner, I can go with the substitution of like x is equal to any number I can substitute. So 1 is a very simplest way to substitute. So let x is equal to 1. Substitute in the equation 1. So the left portion becomes 3 is equal to a into 2, then b plus c into 3. This is the equation. Now substitute the known values first. What is the value of a? We know 3 by 5 into 2 plus b I don't know, but c I know, as it's 1 by 5 into 3. Solve this expression to solve get the value of b. So it is what 6 by 5, right? So I can write 3 minus 6 by 5 equal to uh, I can also take the LCM over here. I can just, otherwise I can solve other way also. 5b plus 1 upon 5 into 3. So it will become 15 minus 6, 9 by 5, and 1 by 3 come over here. So I will be left 5b plus 1 upon 5. 3 ones are 3 threes are, so 3 by 5. So 3 by 5 equal to 5b plus 1 by 5. 5 I get cancelled. So b would be 2 by 5. So now I can read a is 3 by 5, b is 2 by 5, c is 1 by 5. Okay. Now by using this ABC, now I am going to substitute this a, b and c value in the fraction. Okay, I'm just scrolling up. to substitute these values. Remember 3 by 5, 2 by 5 and 1 by 5. Hmm. A is 3 by 5, B is 2 by 5, 2, 1. Hmm. Now I am going to split this like hmm, yeah, right. So now this observe this part. The integral of the question was like x square plus x plus 1 dx upon it was like x plus 2 into the x square plus 1, which was written as now a upon x plus 2. So a already we know it was 3 by 5 upon the factor was x plus 2 dx plus bx plus 3 it was. So bx means 2x by 5 now, plus c means 1 by 5 dx upon x square plus 1. So what is the use of this partial fraction? Now see how can be reduced to a simplest one. 1 upon x plus 2 integration will be log of x plus 2. Since it's a linear one, I can directly apply the formula. And the second is, now if the LCM is 5, so 2x plus 1 by 5, so I can keep 1 by 5 as a constant. So it would be what? 2x plus 1 upon x square plus 1 dx. Now we can see it is just following. I can consider this as I1 is solved. So I can consider here I1, the part of this. Okay. So I1 can be solved separately. You have to show even in the exams. I1 is 1 by 5. Since it is in the form of linear upon quadratic, and we know how to solve the function which is in the form of linear upon quadratic, right? So the denominator derivative is 2x. So we are already having the 2x over here. So we can separate the fraction like 2x upon x square plus 1 plus 1 upon x square plus 1 as the two parts of the integral. So now by substituting it as t, the derivative is available. So it will be reduced to the next part I'm saying. It will reduce to, by substitution technique, the first part is reduced to 1 by t dt. And the second part is completely a perfect formula. 1 by x square upon a square. Perfect formula, right? So finally, the I1 value is reduced to what? 1 by 5 into, it is log t plus it's become tan inverse x. Tan inverse x by a, but a is 1, so tan inverse x. So I can substitute t value over here as x square plus 1, and then I can directly write its value over here to get the final answer. So final answer would be 3 by 5 into log of modulus of x plus 2 plus 1 by 5 into log of x square plus 1. I'm just copying this step over here, plus tan inverse x plus c. So this is the final answer. I hope definitely you have understood how to use a partial fraction and how to solve the ABC values by randomly putting the value of x is equal to 0, x is equal to 1, 2. Sometimes purposely you are selecting some values of x such that you can directly get the value of ABC, right? So now in the same manner, I'm going to take the example number 15. Only the beginning part I will explain. Rest you can do from your end. Because I believe more than me that you will definitely able to do. Okay, चलिए. So हम लोग आगे बढ़ रहे हैं अभी. Wait, go on. Okay, yeah, it is there. Now, just I'm scrolling up to take the next question. Yeah. I'm taking example number 15 right now. With a different pen, I will take. Yeah, it's from NCERT textbook only. I'm taking example number 15. Okay, so now you'll see find the integral of 3 sine pi minus 2, I think it is. Yeah, into cos pi upon 5 minus cos square pi minus 4 sin pi into d pi. Nothing else. dx का d pi है. So if you closely observe this question, the sine theta derivative is cos theta is available in the question. I will go with the first substitution technique. So basically this question is a combination of substitution technique plus partial fraction technique, both. Okay. So first I will go with the substitution technique. So let sine pi is equal to x. So I'm going to do a derivative on both the sides with respect to x. So it become what? Cos pi into d pi by dx is equal to 1. So hence the d pi value is dx upon cos pi. So just substitute this d pi value and sin pi value wherever sin pi is there, substitute x, and you will see the next part how it is going to reduce. So 3x minus 2 into cos pi upon pi minus cos square pi minus 4x into d pi value is there already as dx upon cos pi. So cos pi get cancelled, but entire sum is in the terms of x except cos square pi. You need to convert this into x language. Hence, how can we get x if the expression is in terms of sine? Hence, you need to convert cos square as 1 minus sine square. So, we are converting this one like 3x minus 2 dx upon pi minus 1 minus sine square pi minus 4x. In the next step, I can replace sine pi with x. So it becomes what? 3x minus 2 into dx upon pi minus 1 is 4 plus x square minus 4x. So x square minus 4x plus 4. Now friends, you can see the denominator here completely factorizable, right? You can go with the partial fraction technique again, or else you already studied that how to deal with this type of sums by using linear upon quadratic technique, which you have already studied in the exercise 7.4, or else we wanted to use the partial fraction method, PF method, so you can go with 7.5 technique. There are two ways to solve. So I'm taking the partial fraction technique because we are there only. So now the next step would be like 3x minus 2 dx upon, I can factorize this as x minus 2 the whole square. That's it. So now I can go with the partial fraction technique. So when I'm doing this partial fraction technique, the complete question is going to be divided into two fractions. Like I'm just writing the hint. It's an hint only. I'm not going to solve completely. It's your task to finish. So a upon x minus 2 plus b upon x minus 2 the whole square. That's all. And take LCM and then go for solve A and B. Then ultimately the total fraction is going to be convert into a simplest fraction, and take integral on both the side to solve the rest of the part. So here, if you observe, if we started with substitution technique, then ultimately it leads to a partial fraction technique, or sometimes it leads to a linear upon quadratic, or linear upon under root quadratic, or 1 by quadratic, or 1 by under root quadratic. So it depends whether student want to use this 7.4 exercise techniques or 7.5 partial fraction technique. It depending on the student which method they wanted to go with. So this is example number 15. Now as a last question of the today's discussion, that is example number 12, I would like to take example number 12. Only in the beginning you required some guidelines. That's why I'm taking this question purposely, right? Yeah. So I'm taking the next question. Yeah. So with black pen again, I'm using from where I have started. Yeah. So I'm taking example number 12 from the textbook itself. See, example number 12. Right. What it is there? Find the integral of x square plus 1 upon x square minus 5x plus 6 dx. So first, if you see, the denominator is perfectly factorizable, but it fails to apply the partial fraction. Reason is the degree of the numerator and denominator are same, hence it is a improper fraction. So since it is an improper fraction, we will go with first long division method to convert them into a mixed fraction. Okay, so this is the purpose to do the long division method. And you know how to do the long division method, as you have already studied a lot in the previous standards. So we will go with that only. So we'll start with like x square, 1's a x square. So minus 5x plus 6 will come. Then sign will interchange if you subtract. So this will be get cancelled. So you left with 5x and minus 5. And then this is the remainder, because we cannot go further solve, because the degree of the remainder is less than the degree of the divisor. So hence, this fraction is going to be expressible as like x square plus 1 upon x square minus 5x plus 6. This is going to be written as a mixed fraction like 1 is a quotient, 1 plus the divisor, sorry, remainder is what? 5x minus 5 upon x square minus 5x plus 6. So this is going to be split into two parts like this. So the integration of 1 is x. It is solved already. Now the only this part you need to simplify. Take it as I1. And to solve I1, again we have two techniques. Either student will go with linear upon quadratic technique or go with partial fraction technique. So if you go with partial fraction technique, you need to factorize the denominator, and the factors are x minus 3 into x minus 2. I'm just writing the factors of denominator for your reference. It's x minus 3 into x minus 2. Hence, now you can go with partial fraction technique also, or you can go with linear upon quadratic technique also to get the answer. That's all, my dear. So if you understood this 4 5 sums which I have explained in the class today, so you will definitely able to solve the 7.5 exercise. I'm just writing the questions, number of questions you can solve from your end, right? कि आप अच्छे से आप अपने पूरी पार्शियल फ्रैक्शन टेक्निक जो एक्सरसाइज है वो पूरा का पूरा कर सकते हैं आप. So exercise 7.5, right? You can solve definitely except I'm spelling again, except, right? The question number is 16, 18 and 20. I'll reading 16, 18 and 20. So except these three questions, you will be able to solve definitely the 7.5 exercise from your regular and the famous NCERT test book. So happy learning, keep learning and keep watching the videos and try to like the videos, right? So thank you all of you. We'll meet in the next class with the new concepts, that is what integration by parts. Okay, see you all, take care and bye bye.